So one way of avoiding forming a crossed aldol mixture product, very, very bad outcome, is choosing the reagent so that one of the participants has no alpha hydrogens. Only one enolate can be formed. And let's look at this example. If you take a look at this one has no alpha hydrogens, none. There's no H's on this one, and that's an aldehyde, so you can't add aldehyde H, so you can't deprotonate it. So this one has no alpha hydrogens. So that's great, meaning you can't form an enolate on here. Okay, so no enolate. And this is actually even more electrophilic because of the benzene ring here. So now this one now forms an enolate. So this one forms enolate. Let's say it forms at that carbon. And we're going to show you how the attack takes place. So I'm going to delete this and show you the enolate form of this. So that's a CH2. Okay, so the attack is going to happen like that. Here's yellow. And here's green. Okay, so let's look at the product. Now, so we're going to do the protonation, all of that at once. There it is right there. Now, this one does not last very long, so it will actually dehydrate even at room temperature. So you will get this product. Now, in this example, you don't even need heat, as I said, to get the dehydration to occur because the double bond is conjugated with carbonyl and the aromatic ring. So you have conjugation all over here. Once the enolate of the acetone is formed, it will more readily add to the benzaldehyde than another molecule of acetone, simply because this is more reactive. It's an aldehyde, and then you have a ketone. Aldehydes are more reactive than ketones. So that's one way around it. The other way is use directed aldol addition. So this is something you've seen in the last chapter. So what you do is you form your enolate first, then you add the carbonyl next. You don't mix them all in one round bottom flask. So here, notice what's happening is we have to prepare the enolate of 1-carbonyl with LDA. Remember, it's a very strong base. So with LDA, remember, it favors the kinetic enolate, meaning there. Let's draw this a little bit better. Okay, so this is formed first. And now watch what we're adding. We're adding the aldehyde. This is this right here. So you add this next. Okay. Very well. Now, drawing this. Okay, so we need to be careful. Once again, I like to highlight my alpha and the carbonyl, electrophilic carbonyl carbon. Okay, so yellow is still there. So let's just draw this. Okay, so this is the yellow. Here's this green C, the carbonyl. Again, we're going to do all with protonation. Okay, so let me highlight it. Here's the yellow. And here's the green. Very well. So then we do the dehydration. And I'm going to draw the product down here. Again, going to have a loss of the OH. So remember, the mechanism for this is that these come down. OH is kicked out, so you will form this product. Right here. Actually, let's redraw this. This would be the product. Let's mark it so we can see it. Mark them. Here's the O, C, and here's the H right there.